I'm Roland Ladrick. This is Henry Boltman. We decided to replicate the scene from Imperial March, or the Star Wars movie where Darth Vader is down the hallway and he's holding the lightsaber. It's all dark. It took about 2 weeks to actually build. We've got an actuator which moves the door. We've got a speaker, batteries, and some flashing LEDs and LED strips. And we've got Darth Vader actually in there. You kind of get crouched, but Darth Vader's in there. He's holding his lightsaber. It's lit up. Back here we have all like the guts and all the wires and everything of the circuits. We've got the battery right there connected to, which is strapped to another 6 volt to create 12 volts. We've got our speaker. We've got the actual actuator back there, and the relays and the timers, and yeah, pretty much everything that makes it happen. Yeah.
I'm Blake. This is Rhett. This is our project. So what we got is we got a motor in the center, and you can see the rod and the card attached to it. Underneath we have a 555 timer and a relay switch. The 555 timer it'll change the output signals to on and off, and that'll flip the switch to turn the motor on and off so that it stops the cars. This is the relay. The timer's right here. These are our capacitors that tell the timer when to switch to on and off. That's about it. That light will turn on when it switches, and then it goes. That's about it.
I'm Avery Spitz, and this is
I'm Christian.
So how this works is we have this button here that we allowed people to press, and as people press it, it activates a 555 timer that turns a actuator or motor on that allows the sword to rise. And as it's rising, it's actually turning on a relay. So once you reach the top, the relay switches and allows it to fall back down. And this is all happening with a 12 volt battery. So basically, as the 12 volt battery is powering some LEDs we have in here, as well as a speaker that turns on when we press the button as well. And it's all like systematically working together.
So I can press the button, and
the sword rises.
Out of the stone. And you have some angels singing from the heavens.
Now it pauses for a second, and then it will fall back down by itself. I feel like the hardest part with this is trying to make it fall back down by itself. We spent most of our time trying to figure out that problem, but we eventually solved it. So
my name is Colin Bass. This is Brett Dozier, my partner. We made the DeLorean. The first thing it does is it has a timing circuit, so it switches between power to the wheels and then the lights in the back. So I'll go ahead and demonstrate that. That's here. And there. And the lights are supposed to represent the flames, and of course we have the headlights in the front. And then the second thing we have is 3 DC motors that operate the doors. So we go up and down. Let's go down. This one. Down and up. Just like that. Some issues we had. Reversing the current for the doors was really hard. Since they're DC motors, if you put current in one way, it'll go one way. If we have to reverse it to bring them back down. So that took a while, but we ended up solving it with double pole, double throw switches. The timing right for the wheels and the lights, that was a little difficult. But other than that, it was a super fun project to work on. Proud of the outcome, and that's about it.
So this is our project. My name's Leanna, his name's Matthew. It's a radio disco. So it's supposed to play old music, kind of disco-y. This is our circuit design. The way that it's designed is that the lights are supposed to flicker between red, green, and blue. And the disco ball is supposed to spin while the music plays out of it. Unfortunately, we had some technical difficulties, but if you want to demonstrate. This is the master switch, so it has to be on for anything to work, and it spins very slowly. But the lights do come on. They don't flicker the way we intended, but overall, it works.
My name is James DeVille. This is Colin Rodrigue. And well, we built this. So essentially what it is it used to be a lightsaber, but we had to cut back on some stuff. So essentially how it works is first we flip the master switch, which like usually it's off. So it doesn't let power go to this or that. Press that, show that nothing happens. Whenever you flip that, it allows power to travel to the light, like the light strips, the LEDs, and then whenever you press that, the motor will go on. There it is. So that's how it works essentially, is that it's all connected to a master switch which lets power go to either circuit, which is, we have a motor circuit diagram right here to show all the connections and everything. These LEDs go into a breadboard which connects to the motor circuit breadboard. And that's essentially how it works.
This project, I really like designing our project. My partner did more of the electrical work. I mean, obviously we checked and balanced, each other, but I definitely enjoyed designing better. Well, originally we had a bunch of foam and I was cutting a lot of foam and it was taking a long time. And eventually I would glue it on and it looked really rough and raggedy. Then Mr. Mayoral suggested I use like the foam half tubing, and it made it just look a lot cleaner, and it just made me fall in love with the design better. And it was also easier to wire things up, glue things on, because it was nice and clean and organized.
The designing and the construction where they have now, they've learned all that stuff. And up to that point, I've been sort of leading them on, every step of the way. Now it's pretty much, it's hands off. Now it's, okay, use what you learn. And that's a big step, taking what you learn and trying to design and build something. And for many of these students, most of these students have never worked with electricity before. They've never designed or built anything before. And it's not just the building of the electric circuits and so on, but also the construction of whatever it is that they're coming up with, that they got to put together. Another part that's challenging about that is they only have like 2 weeks at the end to finish it up because of the timing that we have. So they got to do an awful lot in 2 weeks, but it's part of the learning process of, and they're engineering students, and that's the key. Engineers use what they learn and they have to apply it to solve problems.
I would say our 3D print wasn't really working out too well because we had problems with our shaft, stripping our plastic and stuff like that, so we had to overcome that. I would say it definitely opened my eyes to problems and how to solve things and what things are going to be like in the future. Definitely making skills that I didn't have before.
I just love it. It's really the fun part, and it's really it's not all fun because when they're working, of course, when they're doing these things, don't just work out, perfectly. They're constantly have problems and they run into something doesn't work and they got to figure it out. And but just watching that whole process, and believe me, I'm a retired engineer. That's the way it is in the real world in engineering projects. Of course, we work on big projects, rockets, ships. I used to work on ships and so on, and things never work out right. You got to debug things. But I'm watching this happen they're working on small projects over a very short period of time, like I said, 2 weeks, but I see that process going on, and it reminds me of things that, that I experienced on the job, and I say, this is great because, let's face it, what are we doing here? We're not just going to school to go to school. They're going to school here to learn how to be an engineer. And I'm saying this parallels the real engineering world, so that's a good thing. They're learning in this process not only the theory, but they're also learning about what the work is like. So this should help them in the future, in their careers.
After joining this class, I was definitely excited for it, wanting to be an engineer growing up. It also included all kinds of stuff, I wanted to know wiring circuits like we're doing now, building and designing, testing, stuff like that. Real world problems solving, making new friends who also have the same, find the same fun in the same stuff as me.
We do an awful lot that I know that we never did when I was in high school. We never did anything like this. We never did hands-on things or projects. But here at the Satellite Center, if they take this course, you can see for yourself. Not only do they, learn the theory, they got to go through the lectures, they got to do all the math to solve the problems, but eventually, as we go along, they're going to actually use it to build something, to see how it actually works in the real world, and so they apply the theory, and that's what engineering is. It's applied science.
This class is awesome. I love it.
I just love this. I love it here. And when I first came to the Satellite Center, I had no idea how much fun this would be for me. All I know is it's a lot of fun for me. I hope it's fun for them too.
Especially wanting to be an engineer, I was going in.
His stuff was so good.